Okay, so for question 6, your classic acids and bases question, 6a asks you to use the data for pH to work out the percent dissociation. So you're given the pH of 1.83. To turn that into concentration of H plus ions in solution, you do 10 to the power of minus 1.83. So this is the opposite of the log. So pH equals log of H plus equals 10 to the minus concentration of H, 10 to the minus pH. Okay. So after you've done that, you take your concentration for H plus, divide it by the concentration of HNO2, which is given to you as 0.495, times it by 100 for percent ionization. Done. Now for B, you're asked to calculate the Ka. So write the expression for the Ka first. Now to get the H plus concentration, the actual number, you can do the given concentration of HNO2 times 0.03, because that's what you worked out at 2% ionization, roundabout, to get your concentration of H plus, then solve for Ka. Now for C, basically you should have identified that you're making a buffer solution. You can use your Henderson-Hasselbalch, your Ka calculation that you did in part B to work out the pH of that solution. And finally for D, because you have a buffer, and if you've identified you've made a buffer, you can say that the amount of OH added will not affect the pH because you have a weak acid present that is going to take up the OH minus ions that you add. So the OH minus ions are not going to take H plus from the solution. They will take H plus from the weak acid, which means that the H plus concentration in solution doesn't change. This is the concept of a buffer. Okay, hopefully you know that by now.